Welcome to day 9 of me solving an algorithm per day, and today's algorithm is drawing book. A teacher asks the class to open their books to a page number. A student can either start turning pages from the front of the book or from the back of the book. They always turn pages one at a time when they open the book. Page 1 is always on the right side. When they flip a page 1, they see pages 2 and 3. Each page except the last page will always be printed on both sides. The last page may only be printed on the front. Given the length of the book, if the book is n pages long and a student wants to turn to page P, what is the minimum number of pages to turn? They can start at the beginning or the end of the book. Given n and P, find and print the minimum number of pages that must be turned in order to arrive at page P. Okay, so that means let's see, for example, sample input 5 for sample output 0. Length of 5, page 4, 0. Student says I turn from page 1, they need to turn 2 pages, 1, 2. If they start turning from page 5, they do not need to turn any pages. Okay, makes sense. 1, 2, 3, 4, 5. Because that's the last page. I thought that the last page also has just one. Nope. Alright. Okay, let's see. The condition or the constraints are that the length of the book is bigger than 1 and smaller than 1,000,000 or equal, and P is always smaller equal n or bigger equal 1, which means P can be n. So what we could do is we could already check whether we're on the last side or page, right? So that means if page is equal to n or page is equal to n minus 1, return 0, because then we don't need to turn any pages. And also if or page is equal 1, those are the edge cases, correct? Now here we are where P is bigger than 1. If I think about how a page is structured, so basically with 7 pages. Actually 7 pages and 1, 2, 3, 4. There must be a structure behind this. Let's try an edge case or an uneven number here. If we say, for example, 8, 9. If we say this is, for example, 1, 2, 3, 4, 5 pages long, right? Trying to think if it's not even, and P, for example, is 3, right? That would be 2.5, and we would have to turn 1, 2 pages from here, 1, 2 pages from there too. It's always 2 pages. What if we just have 1 less? By 2, page number 2 we have 1. Okay, so how do I know at which page I am? I think if page 2, I would say if it's an even number, if P modulo 2 is an even number, then I can say P minus 1 is the page, right? Except for that one. So for example here, for P divided by 2 plus 1. Plus 1, that's the page, right? So 2 divided by 2 is 1, plus 1 is the page. 4 divided by 2 is 2, plus 1 is the page. 6 divided by 2 is the page, is the page. Okay, so that's the page. What is P? P means 4 or 5, right? And then we have basically the side. I don't know how to call it. It's not a single page, it's like 2 pages. Okay, so then, and if it's unequal, then we want to say plus 1 and then divided by 2. Right? Plus 1 divided by 2, plus 1 divided by 2, plus 1 divided by 2. That's that. This is the side, and now actually we can probably do it like this. Else that should be the side, and now we should be able to know whether or not we want to go from left or right, or whether it doesn't matter. If you go from, so if we are here, for example, that means if n divided by 2 is not an even number, then we want to say n divided by 2 plus 1, so we know this is the middle of it, and then we want to say how many turns would this be? It would be 1, 2 turns, 1, 2 turns. Okay, so for example, if n divided by 2 is not even, then we would have n divided by 2 plus 1 turns, right? It means 5 divided by 2 is 2.5, or actually 2, plus 1 is 3. Is that turns? It's 1, 2 turns. 1, 2 turns. Maybe just that. Well, should be 2. If it's else, which means if it's even, then we would have 1 turn. So then divided by 2, for example, where are we at? We're not really using the side. Yeah, we're not really, this is not the answer. So then we are at the half of it, right? We want to know whether we are below or above of it. So 5 divided by 2 is 2.5. If it's uneven, then we want to say n divided by 2 plus 1 to get to the actual number. And if this one is smaller than side, or let's say if it's equal in side, return n divided by 2, right? Because if in case we are in the middle of it, then we have 1, 2 turns, 1, 2 turns. If it's 2 plus 1 is, or basically if side is smaller than that. That means we're from the left. That means we should be maybe here. And then we have side 2, and then perhaps side -1 is the turn. I'll have to play it out with longer examples. Say 10 and 11. And 12 and 13. So for example, we are having n divided by 2 is 3, so it's 4, that's the middle. And if the page is smaller, like 3, then we have 3 minus 1 is page turns, 1, 2 turns. Okay, but if it's bigger, then we should have it could be bigger, like it could be smaller, it could be even here. Then it's side -1, it's 1 turn, that's fine. Okay, so then, and if it's bigger, then we have maybe n minus side, which leaves us with 2, and then it's 1, 2, or 6 minus n, which leaves us with 1. And if it's an even number, if the size of the book is an even number, we can still look for we should still look for the same, right? Because then we just look for the same without the +1, aren't we? If n divided by 2, that would be 2 is equal side, return n divided by 2. No, sure not, because that's 1 turn and not 2 turns. That would mean here, for example, let's also do an example with 6. N divided by 2 is 3, and that might be equal side, and we want to have how many turns? Side -1, right? This is 1, 2 turns. Side -1 turn. If it's the same, if it's smaller, if side is smaller than n divided by 2, if we are smaller than that, if we're smaller than 3, then we want to say, then we're 2, for example. It's still side -1. Same applies to, say, let's go for a bigger, like 8. Oops, that should be 13. 14, 15. If n divided by 2 it's 1, 2, 3, and this would be 1, 2, 3, 4. Let's see. It's equal side, and if it's smaller, we want to go from left, which means if it's smaller, it could be 2, right? This is 1 turn. It could be this one. It could be, okay, yeah. Else we go from right. If it's bigger than, for example, 4, it could be 5. That means 1, 2, 3 turns. It could be 6, which this is true still, right? And minus side. It could be 1, 2. Okay, let's try that. Let's try this. Wow, okay, this worked. Damn, okay. Lots of cases failed and lots of cases succeeded, so we have edge cases that we didn't cover. Let's unlock one and see why. So input is 7, probably some like even uneven cases. Expected 1 for input 7 and page 3. So we have input 7 and page 3 and we're expecting 1 turn. Oh, we're not page 3, we are, yeah, we're page 3, we're not, and I'm having like kind of the side 3. Okay, so where are we at for that? 7 divided by, it's uneven, right? It's 3.5, which means n divided by 2 plus 1 means this would be 4. If that's the side, return 3. 1, 2, 3. Okay, 1, 2, 3. That looks fine. If side is smaller than n divided by 2 plus 1, then say side minus 1. And how do we get side? We get side by page. It's 3, right? So it's not even. That means we want 4 by 2. That's our side. And side, it should actually go in here, no? Right? Because we have 7 as a size and 3 as the page and 1 turn. So we have 7, that means it's uneven. So 7 divided by 2 is 2.5, which actually should go to 2. Plus 1 is 3, and 3 is, is side. Yeah, it's not the side. Because page plus 1 is 4 divided by 2 is 2. So that's not the case here. And then here, side is 2 for us. If side is smaller than n divided by 2 plus 1, wait, like this, n divided by 2, which should be for the 7, should be 3, it's 4, it's 3, plus 1 is 4. If the side is smaller than 4, which it is because it's 2, right? It would mean return side minus 1, which would mean 1 turn. This is the minimum turn. It should return that one. Let's try again. Maybe it was the parentheses here. Oh, maybe it was this one. Let's fix this one. And here. So then something, let's run it again like this. It runs a little bit too long. Let's minimize it and see. We do have still failed test cases. I wonder if it's, let's go bigger again. And let's see what's wrong here. Input 7 expected, input 7, 4 expected 1. 1 turning page. Really? That should be 2, no? We are at page 4. Expected output 1. Why? This is 1, 2. This is their example, no? Unless, no, we have 1, 2, 3, 4 from the right and we have 2 from the left. Returns the minimum number of pages to turn. The minimum number. It's 1 turn. It says. When it's actually 2. How I understand it. Sample input 6 and page 2, sample output 1. Yeah, and for 3 it should be 1, 2. That was actually literally the case before. Like, was it K7 or what was it? Here, how is that? And then, do you have like 6 or those are locked? See? Wait a second. 5. Oh yeah, size 5 and 4. This makes even sense because we have the size of 5. Wait, we have the size of 5. Interesting. I'm reading something wrong, am I not? This is page 4. Are we talking about these pages or are we talking about turns? They need to turn to 2 pages. Yeah, I think that's... I don't know. Why is this one supposed to be 1 still? From size 7. Maybe because it's from... Wait a second, size 7. Do they mean this in size? Size 7? Size 7. This is the size 7. And we have 4, which means 1. Oh, okay. So I've been calculating with these as n when this is actually n. Okay, let's have a look. Well then, if n divided by 2... No, I think it... Yeah, okay, let's see. Yeah, there's something off. This should be one turn. It makes sense. And this should be 1 turn. It makes sense. Now, if n divided by 2 is unequal 0, which means it's uneven, that means it's 3.5. We want to say just 3, right? Divided by 2, and that's the page. How many turns? Actually, let's do... Here we are. Let's pull this down there. Have a close look like this. That's wrong, for example, here. For that case, doesn't add up. Well, we have this side from where the page is, right? So basically we can use just side to determine going from right or left. Basically, let's see if we have all sides, as in all sides. Because in case of 4, it's 2 plus 1 is 3. That's all sides. If we just had a length of 4. If you have a length of 5, that's divided by 2 is 2 plus 1 is 3. It's still like all sides. So then, for example, if we are looking for side 2, if side is... All sides could also be 5, right? For example, in this case. So if all side divided, let's say modulo 2 is equal to 0, we know it's an even number. And then we can say if all side divided by 2 is smaller than side, basically the other way around. If side is bigger than all side divided by 2, all side minus side, that should be 1. Else we want to say side is, for example, 3 is 1 2 turns, and then maybe side minus 1. And if it's uneven, like here, now we should have covered this one. Now let's cover the uneven. If it's uneven and we have, for example, side 3, we want to say if all side divided by 2 plus 1, that should be the middle, right? Equals side. We can return, this is 3, 1, 2, it's probably side minus 1. I wonder if it is. Let's try, for example, for 7, do we have a 7 example? Okay, So 7 divided by 2 plus 1 would be 4. And if we were to have side 4, that would mean minus 1. It's 1, 2, 3. Yeah, okay, that covers this one, hopefully. Else if, or just else, all side divided by 2 plus 1 is else if all side divided by 2, or I say it's still plus 1. We could say middle. So we don't have to rewrite the same expression. If middle, if the side is smaller than middle, else it's bigger than the middle. If it's smaller than the middle, side minus 1, does it happen for that one too? Smaller than the middle is 3. Yes, 1, 2 turns. Okay, else we want to say all side minus side. All side minus side, which means if it's bigger than that, then that's basically 1 turn, 0 turns. Okay, I think, hopefully, this should work. Now, let's run it. Should have written return here, no? Yep. Run again. I think that was just about the return. Damn, something else. If all side divide. Unresolved identifier all side. All sides. Okay. That works locally, and now the rest test cases. Damn, one simple test case that fails. But this is an edge, let's see. 6, 5, expected 1. Okay. We're pretty close now. It's just one that's left. One edge case we didn't catch. And oh, wait a second. Am I saying, oh, maybe I'm saying here 0, right? Let's just not do that. I don't think we need this. Totally forgot about this. Let's try. Let's submit. Cha-ching! Okay, I forgot about this if statement in the very top. But yeah, solved it. Great. That was today's algorithm. I hope you enjoyed it. It was a little bit challenging, although it was an easy one, supposedly. If you like this format, hit like and let me know. And also leave feedback in the comment section if you have anything to suggest. Also, subscribe to not miss out on tomorrow's algorithm. See you then.